Hello everyone, it's Tutor Mifzal here, and today we will be discussing about hypotonic, hypertonic and isotonic. But before we do that, do follow me on my Facebook and Instagram account at Tutor Mifzal, and don't forget to like, share and subscribe to my YouTube channel. All links are in the description box below. So now, let's begin. Let's say we have three different cells, and these three different cells are immersed in three solvents with different concentration of solute. So in this first diagram over here, we can see that the concentration of solute outside of the cell is lower compared to the concentration of solute inside of the cell. So this kind of solvent or this kind of solution is known as a hypotonic solution. And a hypotonic solution has lower concentration of solute outside of the cell compared to the inside of the cell. So based on the definition of osmosis, we know that osmosis is the movement of water from a low concentration region of solute to a higher concentration region of solute. So what will happen is that inside this cell or inside this solution, alright, water particles would diffuse into the cells by osmosis, and this would causes the cells to expand. So the cell would increase in size due to the amount of water particles entering the cells by osmosis, and at one point the cell would keep on expanding and burst or explode, and this condition is known as hemolysis in the red blood cells, meaning that the cell would burst. So what if we put a plant cell inside a hypotonic solution? When we put a plant cell inside a hypotonic solution, the same thing would occur. Water particles would diffuse into the cells, but the cell would not burst or the cell would not explode. This is because the cell has this structure known as the cell wall, which prevents the cell from bursting. Therefore, it keeps the cell rigid and swollen, and cell needs to be rigid and swollen to maintain or to support its shape or to make sure it is always upright. So in the next diagram over here, as we can see, the concentration of solute inside of the cell and outside of the cell is the same. This solution over here is known as an isotonic solution. So in an isotonic solution, the movement of water going in and going out of the cell is the same, meaning that as water can come into the cell and water can go out of the cell at the same rate. Hence, the net flow of water particles is zero, meaning that water particles going in and going out of the cell is the same. And if you put any plant cells inside an isotonic solution, nothing would happen. The plant cell would still maintain its shape. The same thing goes with red blood cell or any animal cells. And in the third diagram over here, we can see that the concentration of solute inside the solvent is higher compared to the concentration of solute inside the cell, and this condition over here, or this solution over here, is known as a hypertonic solution, meaning that the concentration of solute in the solvent is higher compared to in the cells. So for example, a salt solution is a hypertonic solution. Inside a hypertonic solution, water would diffuse out of the cell through osmosis. This is because, based on the definition of osmosis, we know that water moves from a low concentration region of solute to a higher concentration region of solute. So more water will be going out of the cell compared to water going into the cells. As a result of water moving out of the cell would decrease in size. And when an animal cell decreases in size due to the osmotic pressure, this condition is known as crenation, whereas in a plant cell, this condition is known as plasmolysis. So if a plant cell, we put it inside a hypotonic solution, the plant cell would look like this. Basically, the plant cell would look fat and turgid. And if we put it inside an isotonic solution, the cell would remain its normal shape like this. Water is going inside and outside of the cell at the same rate. If we put a cell inside a hypertonic solution, it will undergo plasmolysis, meaning the shrinking of the cell. Therefore, what would happen is that the cytoplasm of the cell would be pulled away from the cell wall, meaning that the cell would shrink and gather at only one point, and this surrounding part over here is empty, unless it is filled with other fluids like salt fluid, anything that makes it hypertonic. So this condition over here is known as plasmolysis. When this plasmolysed cell is put into a hypotonic solution, so what will happen is that the plasmolized cell would increase in size and become turgid. When these plasmolized cells become turgid, this is known as deplasmolysis, meaning that the cell has restored its original shape or its original condition. That's about it for today, guys. And if you find this video helpful, do follow me on my Facebook and Instagram account at Tutor Mifzal. And don't forget to like, share and subscribe to my YouTube channel. All links are in the description box below. So see you soon. Bye!